Hello students, I hope that you are good, well and fine. So in the previous session, we have covered 1 to 7 problems of this miscellaneous exercise. Okay, so now in today's session, we will be covering the remaining problems of this miscellaneous exercise from 8 to 11 problem. Okay, so we will be uh, jump to our first problem of this session and the eighth problem of this miscellaneous exercise. Okay, so let's see. So eighth problem says find the matrix X so that X multiply with this matrix will be same as this thing. Okay, so first of all, let my X matrix. So first of all, we have to decide what will be its order. Okay, so say n multiply p. Okay, so as you all know that this will be what, as if X and this matrix will going to be multiplied, this means the number of rows here will be same as number of columns here. So this means here we are having number of rows 2, so this means p must be 2, so this means 2. As you can see, this matrix having 2 rows and 3 columns. Okay, so this order is 2 cross 3. Okay, so far so good. Now as you can see, the output or the matrix you will get will be of n cross 3 order. N cross 3 order. So as the output is already given of what order, as you can see, 2 cross 3 order, so this means n also going to be 2. Okay, so this means X order will be 2 cross 2 square matrix. So this means the entries will be A11, A12, A21, A22. Okay, so this means you have to multiply this. Okay, simple. And then you can easily find your entries. Okay, let us see how you are going to do that. Now what? Now just multiply. So this going to multiply with this, you will have what? So A11 multiply with 1, A11 plus 4A12. Okay, A11 plus A4A12. Okay, so far so good. Now what will happen? Now as you can see, what A11 is going to multiply with this. Okay, now A11 2A11 plus 5A12. Okay, now for this 3A11 plus 6A12. Okay, now we will multiply these. 2A1 plus 4A22, 2A21 plus 5A21, sorry, 22. Now 3A21 plus 6A22. Okay, and we all know as this this matrix is equal to this, so this means this is equal to this entry. Okay, now what? Now this implies that this will be same as this entry. Okay, this will be same as this. Okay, so we will compare and we will get our answer. Okay, let's see, we will compare. Okay, now just compare things. You will have what? Just by comparing you will have, as you can see. Okay, so A11 plus 4A12 is equals to minus 7, and 2A11 plus 5A12 is equal to, okay, or you can just pick this thing. Okay, so I'm going to pick this and this. This will be 3A11 plus 6A12 is going to be equal to minus 9. Take 3 common here, or just divide both the side with 3. You will left with this thing. Okay, now what? Now subtract this equation to this. Okay, subtract this equation to this. So this means what you will have, by subtracting you will have, so minus this will be 0, this minus this will be what, a plus of 2A12, this minus this will be minus of 4. So this means A12 entry will be minus of. So your A12 entry will be minus of. Okay. Now what? Now put your A12 entry to any of this equation. You will have what? I will be using this equation. So my a11 a11 plus 2 times of minus 2 is equals to minus 3. So a11 will be minus 4 is equals to minus 3. Taking this minus 4 to the right hand side, you will have this, and this will be 1. So a11 will be just 1. So let me just replace things. So a11 is 1, a12 is minus 2. Simple. Now the same approach we will do to find A21 and A22. Okay, let us see. A21, for A21, so I will be choosing this entry. So this will be equals to 3A21 plus 6A22 is equal to 6, this entry, and this equal to this thing. So A21 plus 4A22 is equals to this thing 2. Okay, now divide every side in this equation by 3. You will have 3, you will have 2, you will have 2. Now what? Now subtract, just by subtracting. So subtract, you will have what? 0 plus you will have minus of 4A22, sorry, minus of 2A22 is equals to 0. So this means your A22 entry will be, so this imply A22 entry will be 0. A22 entry will be 0. So this will be 0. If A22 is 0, now use any of these equations and put A22 value to get your A21. So if I am going to choose this one, so this will be A21 plus 0 is equals to 2. So this means A21 entry will be 2. A21 entry will be 2. So your X matrix will be X is equals to 1 minus 2, 2, 0. Yes, 1 minus 2, 2, 0. 1 minus 2, 2, 0. So you have found out your X. Okay. I hope that it is clear how we got our answer. Simple. Okay. Easy. Okay. Now let us move to next. Okay. As you can see, your matrix not written in a quite the standard form, but X is equals to 1 minus 2, 2, 0. Okay. Okay. Let us move to the ninth problem. Ninth problem, what it says. So ninth problem says, if A is equals to this, such that it follows this thing, that a square equal to I, a square equal to I, then we have to choose our correct option. We have to choose our correct option. So a is alpha, beta, gamma, and minus alpha. A is this. Now I have to find what? A square. A square means a multiply a. This means this matrix is going to multiply with itself. Okay. Now what means this thing? So I'm going to multiply, quite simple. This will be multiplied with this, means alpha square plus beta alpha, sorry, beta gamma. Okay, beta gamma. Okay. Now this will going to multiply with this column. You will have alpha beta minus beta alpha. This means 0. Okay, this means 0. Now this row entries will going to multiply with this column entry. You will have gamma alpha minus alpha gamma means 0. Okay. Now this row entry will be going to multiply with this column entry. You will have beta gamma minus alpha square. Beta gamma minus alpha square. Okay. And you all know what, that a square is equal to identity matrix. So this is what your a square, and it must be equal to identity matrix of order 2. This means this thing. Okay, as you can see, these respective entries follows the thing of equality of matrices. This means that this must be equal to this and this must be equal to this. So from this what you can say, you will have what? Alpha square plus beta gamma is equals to 1, and you will also have beta gamma minus alpha square is equals to 1. So this means you will have what? Let me write it in simple way. So alpha square, so from this what can you get? Alpha square minus beta gamma plus 1 is equals to 0, and from this what you will have? This. So let us check what we are having. So alpha square plus beta gamma, so alpha square plus beta gamma is equals to 1. This is not true, as you can see. 1, this is now cancelled. What about this? 1 minus alpha square, so 1 minus alpha square, okay, 1 minus alpha square, 1 minus alpha square minus beta, so this will also not happen, as you can see. Okay, now 1 plus alpha square minus beta, 1 plus alpha square minus beta gamma, 1 plus alpha square, 1 plus alpha square, okay, 1 plus, as you can see, okay, and the see 1 minus alpha square minus beta gamma is equals to 0. So 1 minus, so are we having this? 1 minus alpha square minus beta gamma, 1 minus, or in other words 1 is equals to alpha square plus beta gamma. 1 is equals to alpha square plus beta gamma. Yes, we are having this. Okay, yes, indeed we are having this thing. Okay, now what? Now, okay, I think I have done one thing wrong. What? That this and this, after multiplying you will have beta gamma plus alpha square. Okay, you will not have this thing. Okay, sorry for that. Okay. So your actual answer will be this: alpha square plus beta gamma is equals to 1. So alpha square plus beta gamma must be equal to 1. So this option C will be your answer. Okay, sorry for that, this will be plus. As you can see, this entry will going to multiply with this, you will have this, and this minus alpha will going to multiply with this minus alpha, so minus minus will become plus alpha square. Okay, I hope that it is clear now. Okay, so your ninth question, the right option will be C. Okay, this one, I hope that it is clear. Sorry for the mistake. Let us move to the next 10th problem. So 10th problem. If the matrix is both symmetric and skew, then what? If a matrix is both the skew and symmetric matrix, okay. So first of all, let me recall you symmetric matrix definition. So symmetric matrix, when we say, so first of all, A transpose must be A. And in skew symmetric matrix, A transpose must be minus. Okay, so far so good. This means what? If you remember a result that in skew symmetric matrices, we know that every diagonal entries must be 0. These must be 0. Okay. And we know that our, say that our X matrix is both skew as well as X is skew plus symmetric. So this means X must be having what? 0 entries at the diagonals. Okay, as you can see. Okay, what about these? What about these entries? Okay, we will see. So as you know, let us take from a little example of let us take a matrix of 2 cross 2. So this means this thing. Okay, we know this is x, okay, and it is both skew as well as symmetric. So if it is a skew, this means these must be going to 0. Okay, this is skew. And skew also says that x transpose must be minus x. So this means that x transpose means 0, a12, a210. This must be going to same as minus of a2, sorry, a12 and a21. This means what? That a21 plus a12 must be 0, and a12 plus a21 must be 0. That sum must be 0. Okay, this is clear. Now it is symmetric also, so this means x transpose must be same as minus x, and from that what you can say, a21 is same as a12. Yes, a21 is same as a12, and a12 is same as a21. This is from where? From symmetric definition. From symmetric. Okay, this is from what? Skew symmetric. Okay, so a21 is same as a12. So a21 is same as a12. So I can write this. Okay, this will be what? Twice of a12. So this means just nothing. A12 is 0, and similarly a21 will be 0. So this means your X matrix will be whole 0 matrix. Okay, so now what about this? A12, sorry, A11, A12, A13, A21, A22, A23, A31, A32, A33. Now this will also give you what? As you can see, these entries will be 0. You all know that. And from symmetric matrices, from symmetric matrices, symmetric x transpose is equals to x will imply that a12 must be equals to a21, a13 is equals to a31, a23 going to be equal to a32. And from what? From skew symmetric, you will have what? That a12 plus a21 is equals to 0. Yes, a13 plus a31 is going to be 0, and a23 plus a32 is going to be 0. So this means you will have this thing. So in general, what is happening, you will always be getting your 0 matrix. So your final matrix will be 0, 0, 0, 0, 0, 0. So you will always get a 0 matrix. Okay, so the correct option will be B. A is a 0 matrix. Okay, A is a 0 matrix. I hope that it is clear. So correct option will be B. As you can see, 0 matrix. Okay, simple. Now, now let us move to the final problem of this miscellaneous exercise, 11th problem. If A is a square matrix and A square is A, okay, A square is A, then I plus A whole cube minus 7A is equal to what? Okay, let us see. So this I plus A, okay, we have to find this I plus A. Okay, first of all, A square is just A, so I can expand this. So what you will get, A cube. Okay, so I identity matrix multiplying how many times whatever the number you want, you will always end up with I. So A cube, I am using what? A cube, sorry, A plus B whole cube. This will be what? A cube plus B cube plus 3AB and A plus B. This is what I am using. Okay, so A, this is this A cube. Okay, now 3AB. Okay, now I plus A, simple, minus 7. Now what? As you all know, I cube is I. This means I cube is I. I multiply I multiply I. I is identity matrix, and you know identity matrix multiplying multiplying what you can say, whatever the matrix, you will get the same matrix. So this means the output will be I, or in general in will be I, where n is what, your integer. Okay, clear? Okay, now a cube can be rewritten as a square a. Now a square is already given that a square is equal to a, so this means a multiply a, and this can be reduced to a square again, and this a square is now a, so this means a cube is a, so I can write this as like this. Now what? Now 3i, we know that I times x, any matrix, is same as x times I. This is same as just x. Okay, so this will be just a. Now I plus a, I plus a. Okay, now using the matrix multiplication property, what you will have, ai this plus 3, sorry, 3a, okay, minus 7. This will be ai will be just this thing, and a square, this will be a square, and a square is equal to a, this will be this. Okay, now I, a plus 3a plus 3a, you will have 7a minus 7a minus 7a. Eventually you will have just I left. Okay, so from this what you can say, your option C will be the correct. Okay, your option C will be your correct option. Okay, I hope that it is clear to you how we got our answer. So option C will be a correct answer. So okay, so we are here at the end of this chapter, matrices. Okay, so we have covered every exercise of NCRT book of this chapter, chapter 3, class 12th, matrices. Let me recall you some of the important properties of from this chapter, and we will end up. Okay, now the basic a plus b can be rewritten as b plus a. Okay, b plus a. Now what? Okay, simple. Same with a minus b. Sorry, this a minus b, you all know, not this. So this abc follows the associative property. This means if you product AB and then product with C, it is same as if you product BC and then the outcome will be product with A. Clear? Now some of the scalar properties. So KA is same as AK. Okay, K is same as AK. Okay, now A transpose, you all know what do we mean by A transpose. So AB whole transpose is same as B transpose A transpose. Okay, clear? Okay, now the inverse also, the AB whole inverse is same as what? B inverse A inverse. The same pattern like this. So we interchange, as you can see, B transpose A transpose. Here we are also interchanging, as you can see. Okay, let me recall you more. Let me recall more properties. Okay, so transpose properties. Okay, and distributive properties also. So K plus L are two scalars. This can be rewritten as Ka plus La, like this, and the same thing will happen for this case also, that Ka plus Kb, you will have this Ka plus Kb. K is what? Our scalar. Okay, now okay, and also if you are having any A square matrix, then you can write this A matrix as the sum of two matrices, and those two matrices, one of the matrix will be skew and one of the matrix will be symmetric matrix, and you will be having this thing. Okay, plus A minus A transpose by 2. This is your skew matrix, sorry, this is your symmetric matrix, and this is your skew matrix, skew symmetric matrix. Okay, I hope that it is clear. And a result, please to remember the result. If you are having a skew matrix, if you are having a skew matrix, then uh, then its its entries diagonal entries must be 0. Its diagonal entry must be 0. Okay, for example, you will having like this in case of 3 cross 3. Okay, clear? I hope that it is clear. Okay, okay. I hope that you must know about this from this chapter. Okay, in order to solve anything. And please be careful with this product of two matrices. As you all know that in general, commutativity doesn't hold in matrices. So this is not equal to PA in general. In general, sometimes they could be, but not in every time. Okay, clear? Please beware of this thing. And also that IA will always give you A or AI. Okay, and one thing also, A inverse A will be same as A of A inverse. A inverse A will be same as this, and this is just nothing but identity matrix. Identity matrix. Okay, clear? Now more properties. A zero matrix. So this is just zero matrix. Zero matrix will give you always 0, or A0 will always give you 0. Okay, 0. Clear? Simple properties we are recalling. Okay, you will have no hard time to remember this, to memorize this. Okay, so these are it. So I hope that you recall some of the properties of from this chapter, matrices, and these properties are going to help you a lot in the upcoming chapter of determinants. Okay, so thank you. We will be back soon with the next chapter, determinants. So again, thank you.